The Uniform Mechanical Code, or UMC, mandates specific protection for lamps installed in walk-in freezers. This code stipulates that all lamps within a walk-in freezer environment must be safeguarded by either a jelly jar or a protective cage. A jelly jar, in this context, refers to a robust, typically glass or plastic enclosure designed to shield the lamp from potential physical impacts and environmental factors. The code emphasizes that the material composing the jelly jar must exhibit a high degree of resistance to breakage to prevent shattering and the subsequent dispersal of glass fragments in the freezer. Simultaneously, if a cage is employed as a protective measure, the UMC mandates that the cage be constructed from a material possessing significant resistance to corrosion. This requirement addresses the potentially corrosive conditions within a freezer environment where moisture and temperature fluctuations can accelerate the degradation of certain materials. The code further requires that both the jelly jar and the cage must be securely affixed to the lamp fixture. This secure attachment is crucial to ensure that the protective measures remain effective under various operating conditions and that they do not become dislodged, thereby negating their protective function. The primary function of either the jelly jar or the cage is to shield the lamp from potential damage arising from falling objects within the freezer or inadvertent contact with personnel operating in the space. Walk-in freezers are frequently used for storing a wide range of items, and the movement of these items can pose a risk to the lamps if they are not adequately protected. Similarly, personnel working in the freezer may accidentally strike or bump into the lamps, leading to breakage. In the event that a lamp is broken within a walk-in freezer, the consequences can extend beyond the mere loss of illumination. Broken glass shards can present a significant hazard, potentially causing cuts or other injuries to individuals working in the freezer. Moreover, damage to the lamp can expose the electrical wiring within the fixture, creating a risk of electrical shock or even fire. Given these potential hazards, the UMC requirements for lamp protection are essential for ensuring the safety of personnel and the prevention of accidents within the freezer environment. While the UMC stipulates that either a jelly jar or a cage can satisfy the minimum requirement for lamp protection, the code implicitly suggests that employing both measures provides an enhanced level of safety. Although compliance can technically be achieved with either a jelly jar or a cage, the added layer of protection afforded by utilizing both is highly advisable. The jelly jar serves as the primary barrier against breakage, preventing the lamp itself from being directly exposed to potential impacts. Concurrently, the cage acts as a secondary safeguard, protecting the jelly jar from being dislodged or damaged. The combined effect of these two protective measures significantly reduces the likelihood of lamp breakage and the associated hazards. In essence, opting for both a jelly jar and a cage represents a more robust and prudent approach to ensuring lamp protection within walk-in freezers, surpassing the minimum requirements of the UMC and providing a greater margin of safety for personnel and equipment. The jelly jar serves a pivotal role in directly safeguarding the lamp from breakage. Its construction for a resilient material, such as reinforced glass or durable plastic, is specifically designed to withstand impacts and prevent the lamp from shattering upon contact with falling objects or accidental bumps. The cage, on the other hand, offers an additional layer of protection by shielding the jelly jar itself from potential damage. It acts as a buffer, preventing the jelly jar from being knocked off the lamp fixture or from being subjected to excessive force that could compromise its integrity. By surrounding the jelly jar, the cage effectively distributes the impact of any external force, minimizing the risk of breakage to the jelly jar and, consequently, to the lamp within. The combined use of a jelly jar and a cage creates a synergistic effect, where the strengths of each protective measure complement the other, resulting in a more robust and reliable system for lamp protection. The jelly jar absorbs direct impacts, while the cage prevents the jelly jar from being dislodged or damaged. This dual-layered approach significantly reduces the overall risk of lamp breakage and the associated hazards, such as cuts from broken glass and electrical shock from exposed wiring. Furthermore, the enhanced protection afforded by using both a jelly jar and a cage can extend the lifespan of the lamp itself. By minimizing the risk of breakage, the lamps are less likely to be damaged prematurely, reducing the frequency of replacements and the associated maintenance costs. This can be particularly beneficial in walk-in freezers, where lamp replacement can be challenging and time-consuming due to the cold temperatures and confined spaces. In addition to the safety and cost-saving benefits, the use of both a jelly jar and a cage can also enhance the overall appearance of the lighting system in the walk-in freezer. The cage can provide a more aesthetically pleasing look, while the jelly jar can help to diffuse the light, creating a more uniform and comfortable illumination level. This can improve visibility within the freezer, making it easier for personnel to locate and retrieve items. In conclusion, while the Uniform Mechanical Code permits the use of either a jelly jar or a cage for lamp protection in walk-in freezers, opting for both measures provides a significantly enhanced level of safety, reduces the risk of accidents, extends the lifespan of the lamps, and can improve the overall appearance of the lighting system. The decision to invest in both protective measures represents a prudent and responsible approach to ensuring the safety and efficiency of walk-in freezer operations. Considering the potential consequences of lamp breakage, such as injuries from glass shards and electrical hazards, the added protection afforded by using both a jelly jar and a cage far outweighs the minimal cost increase. By prioritizing safety and implementing comprehensive protective measures, businesses can create a safer and more productive working environment for their employees. Therefore, it is strongly recommended that both a jelly jar and a cage be installed for all lamps in walk-in freezers to ensure the highest level of protection and compliance with safety regulations. Moreover, it's crucial to ensure that the selected jelly jar and cage meet specific standards for durability and corrosion resistance to guarantee their effectiveness over time. The UMC emphasizes the use of materials that can withstand the harsh conditions typical of walk-in freezers, including low temperatures and high humidity. Selecting components that are specifically designed for these environments will prolong their lifespan and minimize the need for frequent replacements. Regular inspection of the jelly jars and cages is also essential to identify any signs of damage or wear. Cracks, chips, or corrosion can compromise their protective capabilities and should be addressed promptly. Replacing damaged components ensures that the lamps remain adequately shielded and that the risk of accidents is minimized. Furthermore, it's important to consider the specific requirements of the lamps being used in the walk-in freezer. Different lamp types may have varying sensitivity to temperature fluctuations and impact. Selecting jelly jars and cages that are compatible with the chosen lamp type will optimize their performance and extend their lifespan. For example, certain LED lamps may require specific enclosures that provide adequate ventilation to prevent overheating. In addition to the physical protection provided by jelly jars and cages, it's also important to consider the electrical safety aspects of lamp installation in walk-in freezers. Proper grounding of the lamp fixtures is essential to prevent electrical shock hazards. All wiring should be installed in accordance with applicable electrical codes and standards. Furthermore, it's advisable to use ground fault circuit interrupters, or GFCIs, to protect circuits that supply power to the lamps. GFCIs can detect even small leakage currents and quickly interrupt the circuit, preventing electrical shocks. Adequate lighting levels are also crucial for safety and productivity in walk-in freezers. Insufficient lighting can increase the risk of accidents and make it difficult for personnel to locate items. It's important to select lamps with appropriate light output and to position them strategically to ensure uniform illumination throughout the freezer. Regular maintenance of the lighting system is essential to maintain adequate lighting levels. This includes cleaning the jelly jars and cages to remove any accumulated dirt or ice, as well as replacing any burned out lamps promptly. By addressing these factors, businesses can ensure that their walk-in freezers are equipped with safe, reliable, and efficient lighting systems that meet all applicable code requirements and promote a safe and productive working environment. The Uniform Mechanical Code serves as a valuable resource for ensuring the safety and efficiency of mechanical systems, including lighting in walk-in freezers. By adhering to the code's requirements and implementing best practices for lamp protection, businesses can minimize the risk of accidents, reduce maintenance costs, and create a more comfortable and productive working environment for their employees. Ultimately, the investment in comprehensive lamp protection is a worthwhile investment that contributes to the overall success of the business. Firstly, selecting the appropriate materials for jelly jars and cages is paramount. These materials must withstand the harsh environment of a walk-in freezer, including low temperatures and high humidity. Secondly, ensuring secure attachment of the protective measures to the lamp fixture is crucial for their effectiveness. Thirdly, regular inspection and maintenance of the lighting system are essential to identify and address any potential hazards or deficiencies. Fourthly, considering the specific requirements of the lamps being used in the freezer is important for optimizing their performance and lifespan. Fifthly, implementing appropriate electrical safety measures, such as grounding and GFCI protection, is vital for preventing electrical shock hazards. Sixthly, maintaining adequate lighting levels is essential for safety and productivity within the freezer. Seventhly, adhering to the Uniform Mechanical Code and other applicable standards is crucial for ensuring compliance and minimizing the risk of accidents. Eighthly, training personnel on safe work practices in walk-in freezers can further reduce the risk of accidents and injuries. Ninthly, regularly reviewing and updating safety procedures can help to ensure that they remain effective and relevant. Tenthly, fostering a culture of safety within the organization can promote proactive hazard identification and prevention. By following these guidelines, businesses can create safer and more efficient walk-in freezer operations. The code exists to protect people from the hazards associated with broken lamps and exposed wiring. While the minimum code might allow for just one form of protection, such as a jelly jar, best practices dictate using both a jelly jar and a cage for maximum safety. Think of the jelly jar as the primary defense against direct impact. It's designed to be tough, but it's not indestructible. The cage acts as a secondary layer of protection, preventing the jelly jar from being dislodged or broken by larger objects or accidental bumps. This redundancy is critical in a busy walk-in freezer where things are constantly being moved around. Also consider the cost of replacing a broken lamp versus the cost of installing a cage. The cage is a one-time expense that can prevent multiple lamp replacements, saving money in the long run. Furthermore, broken lamps can lead to downtime and disruption of operations, which can also be costly. Moreover, the type of lamp used can also influence the choice of protection. Some lamps are more fragile than others and may require more robust protection. LED lamps, for example, are generally more durable than fluorescent lamps, but they can still be damaged by impact or vibration. Therefore, it's important to consider the specific characteristics of the lamp when selecting the appropriate protective measures. When selecting jelly jars and cages, it's important to choose products that are specifically designed for use in walk-in freezers. These products are typically made from materials that are resistant to corrosion, moisture, and extreme temperatures. They also often feature designs that allow for easy cleaning and maintenance. Furthermore, it's important to ensure that the jelly jars and cages are properly installed. This includes ensuring that they are securely attached to the lamp fixture and that they are properly aligned. Improper installation can compromise their effectiveness and may even create additional hazards. In addition to the physical protection provided by jelly jars and cages, it's also important to consider the lighting requirements of the walk-in freezer. Adequate lighting is essential for safety and productivity. Insufficient lighting can increase the risk of accidents and make it difficult to locate items. Therefore, it's important to select lamps that provide adequate light output and to position them strategically to ensure uniform illumination throughout the freezer. Regular maintenance of the lighting system is also essential to maintain adequate lighting levels. This includes cleaning the jelly jars and cages to remove any accumulated dirt or ice, as well as replacing any burned-out lamps promptly. By addressing these factors, businesses can ensure that their walk-in freezers are equipped with safe, reliable, and efficient lighting systems that meet all applicable code requirements and promote a safe and productive working environment. Walk-in freezers present unique challenges for lighting systems due to the extreme temperatures and high humidity. These conditions can accelerate the degradation of lighting components and increase the risk of failure. Therefore, it's important to select lighting systems that are specifically designed for use in these environments. These systems typically feature components that are resistant to corrosion, moisture, and extreme temperatures. They also often incorporate features that help to prevent condensation and ice buildup. Furthermore, it's important to consider the energy efficiency of the lighting system. Walk-in freezers consume a significant amount of energy, and lighting can account for a substantial portion of this energy consumption. Therefore, it's important to select energy-efficient lamps and lighting controls to minimize energy costs. LED lamps are a popular choice for walk-in freezers due to their high energy efficiency, long lifespan, and low heat output. They also typically require less maintenance than other types of lamps. Lighting controls can also help to reduce energy consumption by automatically turning off the lights when the freezer is not in use. Motion sensors and timers can be used to control the lights based on occupancy or time of day. In addition to energy efficiency, it's also important to consider the lighting quality. Adequate lighting quality is essential for safety and productivity. Poor lighting quality can increase the risk of accidents and make it difficult to locate items. Therefore, it's important to select lamps that provide adequate light output, color rendering, and glare control. Color rendering refers to the ability of a lamp to accurately render the colors of objects. Good color rendering is important for tasks that require accurate color perception, such as identifying food product. Glare control refers to the ability of a lamp to minimize glare. Glare can cause eye strain and fatigue, which can increase the risk of accidents. Therefore, it's important to select lamps that have good glare control characteristics. By addressing these factors, businesses can ensure that their walk-in freezers are equipped with lighting systems that are safe, efficient, and provide adequate lighting quality. The goal is to create a safe and well-lit environment where workers can easily see and avoid potential hazards. It's a proactive approach to safety that can prevent accidents and injuries. And don't forget to consult with a qualified electrician or lighting specialist to ensure that the lighting system meets all applicable code requirements and is properly installed. They can provide valuable guidance and expertise to help you make the best choices for your specific needs.